Hey everyone, today we're working on lesson 9, day 1, estimating roots. Our objective is to estimate square and cube roots, and please make sure that you have something to write on, something to write with, and to be watching for areas in the video where I ask you to try some problems and come back and check your answers. So to get things started, let's talk about what our goal is when we're estimating square and cube roots. You know that the square root of 8 is not a whole number because 8 is not a perfect square. The number line below shows that the square root of 8 is between 2 and 3. Since 8 is closer to 9 than 4, the best whole number estimate for the square root of 8 is 3. So what this means is we're not used to seeing numbers with a radical sign above them and thinking of their value. So we're looking at what the value of the square root of 8 actually is. So the best thing we can do is compare the square root of 9, which is 3, and the square root of 4, which is 2. We want to pick the closest two perfect squares to the square root of 8, one that's smaller and one that's larger. So the whole number value of the square root of 9 is 3. The whole number value of the square root of 4 is 2. So knowing that the square root of 8 is very close to the square root of 9, we would say that the square root of 8 is very close to the value of 3. So it's a little more than 2.75. It's probably about 2.8, 2.85. So our answer to what is the closest whole number estimate of the square root of 8 would be the value 3. And we could write that out with just a simple expression like this. The square root of 8 is approximately 3. So let's take a look at an example. Estimate the square root of 83 to the nearest integer. The largest perfect square less than 83 is 81. The smallest perfect square greater than 83 is 100. So we're looking for an estimate of the square root of 83. We know the square root of 100 is larger than the square root of 83, and that's whole number value is 10. And the square root of 81 is smaller than the square root of 83, and its whole number value is 9. So we can plot these values on a number line, and just looking at the value of the square root of 83, we know that that's going to be way closer to the square root of 81 than the square root of 100. And we can really quickly prove that by saying, obviously 83 minus 81 is 2, and 100 minus 83 is 17. So the square root of 83 is obviously way closer to the square root of 81. So to write out our final expression, we would say the square root of 83 is approximately 9. Now let's take a look at an example where we're looking at estimating a cube root of a value. So here we're being asked to estimate the cube root of 320 to the nearest integer. So the largest perfect cube less than 320 is 216, and the cube root of 216 is 6, and the smallest perfect cube greater than 320 is 343. And the cube root of 343 is 7. So I just create a number line, and I put my larger cube root on the right. So 7 cubed is 343. So the cube root of 343 is 7. And 6 cubed is 216. And the cube root of 216 is 6. So I'm trying to figure out which one of these values the cube root of 320 is closer to. So I like to put just a hash mark in the middle with my 6.5. And I can tell just by observation that the cube root of 320 is going to be closer to 343 than it is to 216. So I would say the cube root of 320 would fall approximately in here. And remember, I don't have to find the exact value of the cube root of 320. I just need to know, is the cube root of 320 closer to 7 or closer to 6? And it's closer to 7. So I can write out my expression like this. The cube root of 320 is approximately 7. So let's take a look at A. We're being asked to find an estimate for the square root of 35. So what I do, I make my number line, and I try to find a perfect square that's larger than 35 and smaller than 35. So I know that the square root of 36 is larger, and that value is 6. And then the square root of 25 is smaller. That value is 5. There's my halfway point. So obviously, the square root of 35 is going to be closer to the square root of 36. So the estimate for the square root of 35 would be approximately 6. B, we're looking for an estimate of the square root of 170. Again, I make my number line. I find a perfect square that's larger and a perfect square that's smaller. And if you're not sure, you can kind of guess and check using your calculator. And for example, maybe you try 12, and I know that 12 squared equals 144. Well, that looks pretty close. If I go 13 squared, that's 169. That's even closer. So I found my smaller value. The square root of 169 is smaller than the square root of 170. So the square root of 169 is 13. So I know then my larger value is going to be 14. And to find out what the square root value is, I take 14 squared, and I get 196. So the square root of 196 is 14. So looking at which of these two values the square root of 170 is closer to, that's really obvious that it's going to be closest to the square root of 169, which is 13. So I would write my answer as the square root of 170 is approximately 13. And then finally, let's take a look at F. Looking for the estimate of the cube root of 129.6. So I can have decimal values, and it's not a perfect square, so I obviously won't get a nice clean number. But now I have to start looking at cube roots that would be close to the cube root of 129.6. So I can kind of do a guess and check thing like I did before. 4 cubed I know is 64, it's too small. 5 cubed is 125, that's pretty close. So that's probably my lower value. And then 6 cubed is 216. So I found the two values that the cube root of 129.6 will be between. On the low end, it will be the cube root of 125, which is 5. And on the high end, it'll be the cube root of 216, which is 6. So I can tell right now that the cube root of 129.6 is going to be closer to the cube root of 125. So the whole number estimate would be 5. And I would write my final answer as the cube root of 129.6 is approximately 5. So as far as an assignment today, for lesson 9, day 1, no assignment at this point. If you'd like, go back and review the practice problems from the lesson and maybe try the 3 that we did not do. And we will pick up with lesson 9, day 2 tomorrow.